Okay, advanced word problems number 2. We are moving on, but the thing is, it's a lot like the last lesson in that we can rewrite a variable in terms of another variable. And then the types that we're going to deal with today are perimeter problems. So it's a continuation of the last lesson where we worked on rewriting a variable using an equal expression containing a different variable. Remember, the goal of this is to change an equation from having 2 or more variables into an equal equation containing only one variable in order to solve. Okay? So you should know what perimeter means. It measures the distance around an object. It is found by adding all the sides. Okay? So the equation for finding perimeter of a rectangle is length plus width plus length plus width, right? Length plus width plus length plus width. Or if you combine like terms, there's 2 L's plus 2 W's. Okay, I don't really care which one you use. Okay, but yeah. So, first example. The length of a rectangle is 6 inches more than its width. The perimeter of this rectangle is 24 inches. Find the dimensions of this rectangle. So it is a good idea to draw and label a picture representing the situation. So it's a rectangle, right? Well, I would just basically copy that. Okay, well, that's great, but we still have the problem, right? We still have a problem in that we have an L and a W. We can't have both. Okay, so what do we do? Well, the relationship between the length and the width is that the length is 6 inches more than the width. That was in the problem. The sentence that shows the relationship between the two is very key in solving these problems. We can use that information to help us rewrite our variable in terms of the other. So the length, I'm going to take the length and I'm going to replace it with L, that's equals 6, well we already know what 6 is, more than the width, so plus W. Now that's nice because that relates the width to the length. And what I can do is anywhere I see the length, that expression means the same as L. So instead of L, I can put 6 plus W. Instead of L, I can put 6 plus W. So, and by the way, this is the equation for perimeter, right? Well, I can do now, instead of L, I can put that in place there too. So 2, and I can put 6 plus W in its place. So then my equation is 2 times 6 plus W plus the 2 W's that were already there equals the perimeter. But I knew the perimeter is 24. So I can put the 24 in for the P there. And now we have an equation, a multi-step equation like we did in the last unit. Distribute, and I get 12 plus 2W plus 2W equals 24. 2W plus 2W is 4W. I still have the 12 here. Subtract 12, I get 4W equals 12. Divide by 4, I get W equals 3. So that gave me the width. So the width was 3 inches. And I can see the label there is inches. So how do I find the length? Well, you can go back to the relationship between the length and the width. If the width is 3, add 6 to it and you get the length. So 3 plus 6, 9 inches. Okay? There's 2 more on the back. I'm going to do the second one with you, and I want you to try the third one. All right, so the width of a rectangle is 2 centimeters less than its length. If the perimeter of the rectangle is 56 centimeters, what is the width of this rectangle? Notice right away that this problem is only asking for the width. Once you find that information, you can stop. So I'm going to label it length, width, and now I want to look for that relationship sentence. The width, the length, they're in the same sentence. That's relating the width to the length. So the width of a rectangle, so W, is 2, remember with less than, that's subtraction, but it switches the order. So it's the length minus 2. Now anywhere I see a W, I can put L minus 2 in its place. There goes W, L minus 2. There goes W, L minus 2. Now, a lot of you are probably thinking, well, last time we took the L out and put W in its place. This time we're taking the W out and putting L in its place. You can go either way, depending on what the problem gives you. So my equation now is 2 lengths plus 2 of those, lengths minus 2, equals my perimeter, which is 56. Solve that, you get 2L plus, I'm going to distribute the 2, 2L minus 4 equals 56. Put them together, 4L minus 4 equals 56. Add 4, I get 4L equals 60, and L equals 15. A lot of people think they're done here. They're not. Remember, you're looking for the width. I don't have the width, I have the length. How do I get the width? I just plug it back in. I put it right in there. So 15 minus 2, the width would be 13 centimeters. Okay. I'm going to go ahead and make a decision on the fly here. I don't want to let you just try this on your own. This is kind of challenging, so I'm going to do another one with you here. Okay? Notice how I didn't even read the problem and I know what I'm doing. I'm setting that up. Okay, I'm looking for the dimensions, so I need both length and width. I know that. Dimensions means both. So I'm looking for the length and the width. So let's find the relationship between the length and the width. The length of the garden is so length is 3 more than, so 3 plus twice the width, 2W. So now anywhere I see an L, I can replace it with 3 plus 2W. So now I've got 2 of those. And I've got 2 original widths. And that equals the perimeter, which is 36. Notice that we follow pretty much the same idea for all of these. So I'm going to distribute the 2. So 2 times 3 is 6. 2 times 2W is 4W. Don't forget that plus 2W. So that's 6 plus 6W equals 36. Subtract the 6, I get 6W equals 30. Divide, I get the width is 5. 5 what? Yards. Now the length. I can take the 5 and put it right back in for W. So 3 plus 2 times 5 would be 3 plus 10, which is 13 yards. Okay, and that is what perimeter problems look like. But keep in mind, the key thing is this right here. Is this right here. Relating the width to the length, relating the length to the width. What's the relationship? And that allows us to rewrite the variable in terms of another variable.